Good to see everybody on. Hello, everybody. My name is Kevin Kawchek. I'm the founder CEO of Chemical Q Device here for Thursday, April 25th, 2024. So I'm going to cover over Llama 3. So it just came out exactly 1 week ago. Fine tuning is something you could do with the large language models. You can also do RAG, Retrieval Augmentation Generation, and prompt engineering a little bit less these days, but especially with RAG these days is what you'll find. So it's kind of like taking a diamond in the rough. And a lot of times that it's not that rough these days. I mean, like the original base model, if it's the 8 billion parameter, especially if it's the 70 billion parameter, they're well advanced these days to handle, they're trained on, 15 trillion tokens. So associate that, that's like the numerical version of words. It's not always the exact representation of the word, but it's using numbers instead of words. And when you train on your own set, it's influencing the parameters. So in other words, if you have something kind of like interesting, unique, that spits everything out in biochemistry into a certain like smiles format that is probably not originally trained on, then that would something you actually train, like machine learn train this large LLM. And a lot of times you're just doing a certain percent of the parameters. You're not doing, 100% of them. And on top of that, a lot of times you take approximations of the parameters. You don't actually are using, 100, or you're not using the full weights of these, what it shows up in the megabyte size. So basically, here's a rough example. So this is taking DaVinci GPT-3. It's very similar for Llama. Tell me how to fine tune a model, and it gives back all these other answers. Now, they say with the fine tune model, whatever they use to fine tune it on, so this text, is what they're calling it, they're able to get this more kind of coherency in the response back. And this is where everything that I'm talking about falls in line. It's the quality of the output, and this can be affected with fine tuning. So meaning you have to retrain a certain number of parameters, usually not the whole thing. You can actually retrain the whole model, which might be an issue for you because Llama, with Llama 3 with Meta, they spent, I think, $100 million to, perfect these things as a good base model. And I shouldn't say perfect, but to make them really good. Now, there's different ways of fine tuning. Again, this will look, I've been working off an Unsloth demo for one, and then a different one for RAG with Llama 3. Now, this particular one, they say self-supervised, listening to your own heart as far as your training corpus. And I've already come across supervised. So supervised learning, I did a protein generator model, and it basically, the data set is based on lab values of these, force values that you get in lab, and they're labeled, okay? And keep in mind, even in today's awesome, LLMs, they're not usually fully unsupervised. There's some degree of making them better with supervised data to get the accuracies up at least. And you see this third one with reinforcement learning. So there's different ways to fine tune. Now, RAG is probably, when I come across, it seems like it's kind of like the area that's buzzing the most. NVIDIA put up a post, I think it was November of last year, and this is moving so fast. And I attend other machine learning AI groups, and basically, they keep saying RAG over and over again, and prompt tuning, which we're not going to cover as much today. But basically, it's interjecting with some data. So in this case, it's showing it with the search engine. Now, I've been doing it on a separate data directory, like it's a heart disease directory, and I'll show you some of the results a little bit later. But basically, instead of taking the LLM's word, literal word for the specific answer, it can use this most up-to-date information from the web. They say it's different from web scraping. It tends to follow under more, and again, it's up to whoever uses it. It shouldn't have that negative connotation that you get with web scraping sometimes. Okay, so that's what happens here. So it gets this, it uses a search engine. It doesn't have to be public. It doesn't have to be private. It could be either or. I've used it like a private data set. I found out later it was actually trained on that too, but using RAG in my directory in specific, it actually got more information than when it went through its first go, collecting this heart data set from the UC Irvine's machine learning website. So you see, and you get this result. So LLM. So I would definitely check out this I put it up on my LinkedIn. That's the easiest way to find it. It's called Code Cloud. If you're just starting off with LLMs, you have to know the basics, and it does talk about some advanced things as well too. And, so that's where this one was in specific from. So this one was a little bit more advanced. So it says building production ready RAG applications. So RAG is so cool because you don't have to retrain. You can fine tune or based on a retrained model or whatever as a starting point. But typically you should give your first go, with RAG, and I'll show you some of the other pictures or diagrams and the reason why. Now they say less expensive, easier to implement, lower latency and costs are these what they call table stakes. And again, this is going to get really in depth in the next couple of weeks here. So better parsers, chunk sizes, so this is basically when the data is first passed through metadata filters. Now the advanced retrieval, re-ranking, recursive retrieval, embedded tables, small to big retrieval. The biggest thing that I've collected so far from RAG is basically it's based on, instead of just taking the word for the LLM, whatever answer, it's now using the web to pull information, and it has the ability to cite sources. So that's a huge thing that you typically don't get. Now, I was using meta.ai, and just like I would use ChatGPT or Hugging Chat. And this, of course, is based on Llama 3. So why not use it? And I could probably do a comparison between meta.ai's, their web chat interface, and then my, say, RAG or fine tune or combination of those, compare those, the outputs, basically. Okay, so then here's fine tuning, embedding fine tuning, LLM fine tuning. And agentic behavior means these agents, and it's kind of like the things that's coming up. NVIDIA talks about these at GTC, their previous conference, which is probably about a month ago. These are agents. At this stage, it's going to be software agents talking to software agents in a similar way that humans would get software work done. Okay, so over here is on one side, typically anytime you have to retrain, it's kind of, usually you're not correct the first time. And again, $100 million. And I think even much more for GPT with OpenAI's, like some of these, I don't know if it's 3.5 or 4, I believe it was 4. So where does all this fit in? Okay, so we have prompt engineering. Now, if you go to these meetups, they'll talk about it. And it's basically, it could be as something as like, you have to get really good at selecting the right query to put into, meta.ai. That's one way of looking at it. And I believe it gets much more in depth with that. But they say easy to work with, rapid prototyping, intuitive. Okay. Now you have RAG, so it's basically, it can be real time, right? Dynamic knowledge in the prompt, and connect external data sources. Now, somebody else on LinkedIn posted this really interesting article. They think some of the portion of healthcare does not want to use any LLM because it's a web-based interface, and they can't accidentally send any patient information because, say, OpenAI collects the information. And I think even Meta would if you're logged in with your Facebook account. So the solution seems to just have, local whatevers, open source like a Llama, and then use RAG in specific. And when you get the new data coming in, that way you're not providing everybody, this potential patient data, these types of things. So it's more of a, the model's locked. And by the way, all these models, let's see, the Llama 3, 8 billion that I focus on, that was trained in March of 2023. Okay. And then the 70 billion was trained in December. So these things, even though you're accessing them on the web, they're not like, fully trained over. And I believe they use some aspect of RAG. So, that gives them some, because on meta.ai, you can actually get the references, which is kind of interesting. Now, fine tuning, and I've done this a bunch of times, it's basically you're starting with, and when you use the term pre-trained, that means it's the Llama 3 8 billion parameter or the Llama 3 70 billion parameter that they trained on. Okay, so that's your pre-trained model. And then when you go to, fine tune, you typically incorporate a data set that is going to be highly reflective of the type of data that your organization is going to be passing in over and over and over again. So for instance, it's not going to remove, if you're fine tuning, you're not going to remove all 8 billion parameters, right? It's more like, I think in one of these demos, they said between 1 and 10% of the parameters are now going to be more focused on the data set that you're fine tuning on. So it depends on which, you kind of have to find your way with this, because some of these, they lean towards more fine tuning. Others are more towards RAG. I'm probably a little bit more towards RAG, but it doesn't mean that you have to pick only one. And a lot of times say have a fine tuned model, now you're doing RAG on, and it's going to be a combination of these things. Okay. So here's the technology comparisons here. And I believe these are rough estimates, but they're basically saying this is the amount of accuracy you can get if you use prompt engineering, RAG, fine tuning, or train from scratch. Now, most people, if you were to train from scratch on, Llama's, 8 billion parameter model, that'd probably be an issue for you, because you're going to lose a lot of that context that the original model had, right? It's like 15 trillion tokens with all the like kind of associations to words. And it's just been an enormous amount of data that it was trained on. So this is how they put this. And again, this is just a rough estimate, but it kind of gives you an idea of what's going on. So say, for instance, you see, they also did other charts for, effort, the amount of human effort it takes to do these things, complexity. So the amount that's, involved with this, or total cost of ownership, as far as like, when you go to fine tune or retrain a model, that's doing like machine learning on a good portion for fine tuning, or the whole thing for training from scratch. And the next one that they had was interesting. So they said flexibility of changes. And again, this is just something to think about, right? And they're not always 100% like this is set in stone. But in general, they're saying RAG, or this retrieval augmentation. And I've seen other places too. If you attend some kind of good machine learning groups on the weekends, they'll mention RAG a lot too. Okay, so where does all this fit together here? Is basically this this on the diagonal is representing RAG and what all it could do. And again, the good thing with this is typically you're not retraining the model, you're not significantly adding to the size of it. It's going to be fast, and it's more like, and I'll show you with some of the results that I had, it's more like you're using an additional framework, RAG framework plus LLM. So they say LLM fine tuning will go out to prompt tuning. And this is something that I'm not going to cover too much, but it's something that comes up a lot in these machine learning meetups, is prompt tuning and RAG as well. Now, this is a good diagram here because it basically shows, so simple prompting on the left, fine tuning. So I'm going to show you some examples of that here. And then basically, so you have your pre-trained, so pre-trained LLM in this case would be like a Llama 3, 8 billion. And you're fine tuning on your task-specific data set. So in one, I chose kind of a more standard one, and one, I chose molecular instructions for that. And then that creates your new fine-tuned model, and you're going to get different generated responses because it's also picking up on the parameters, based on the task-specific data set, as opposed to just what Llama, their effort that they put in. Now, here's a RAG. So they use the term data store. So again, I think this is kind of like the near-term future for hospitals and medical and specific to use something that's local and then to still get updated information. So this doesn't have to be, something that is online. They can keep everything offline, for instance. And again, the big thing that I don't think most people know is that these models are not retrained all the time. Like the core models for the 8 billion parameter, like I said, that was March of 2023, they finished. And they're still, implementing, they can't implement RAG and those types of things in the as part of like an updated model. Now on the right is actually, I believe this is more of like a RAG, fine-tuned RAG model, because you see fine tuning, you see the data store. So when you put these things together, and there's other techniques too, but you're basically saying, like, if I did X, Y, and Z, like the data's too dirty, you need to clean the data, or you need to do this, or you need to do that, how will it affect the output if I fine tune the model to, retrain on a 10% of the parameters, or what about using RAG? And that seems to be the thing right now is with RAG. So basically, this one in specific, so you can go on to meta.ai. I would highly suggest if you use ChatGPT 2, just spread it out. And it might not be as fast as the 3.5 turbo on the OpenAI, but if you're working on Llama anyways, why not? And I think with theirs, because based on a query that I asked them, I said, what is this based on? And I had to ask it a couple of times. So I believe the chat based on meta.ai, and I'll show you the interface later, is based on the 80 billion parameter, because the 400 billion parameter is not quite ready yet. So if you type in the word imagine on a faster PC or whatever, every word you type. So imagine, I did this on my phone initially, imagine llamas. And I saw a demo of this. It's really amazing. So when you just type in llamas, it'll give you a specific picture. Okay, so this is basically a text to image generation. And when you type in hopping, it'll change the picture too, based on, its trained data and what it thinks those 3 words. Now, if you like the previous one better, then just remove the word hopping, and then you're back to imagine llamas. So the key is it's meta.ai. Again, it's based on Llama, and it's of interest to me because the open source model has been used for Llama 2 with a bunch of different chatbots, medical chatbots that have passed medical exams, and mine would be more focused on biochemistry and medicinal, like drug discovery. So this is one of them. So this is basically the Alpaca clean data set. This is an original Stanford work, and then somebody cleaned up the data. And what I basically found with this one is I could use a very low rank in LoRa, so it's associated with smaller parameter sizes with this associated alpha. And I actually got really good outputs for it. I uploaded it to Hugging Face. Now, when you do this, you have to be very careful to also test against the base model, which would be Llama 3 8 billion. Now, like I said, if you go to meta.ai and type in the same query that you're doing in your model, I think theirs is the 70 billion and whatever versus whatever, which one you're using. So the moral of the story is it's not always the case that your fine-tuned model is significantly better than the original. Now, this Alpaca clean data set is more just regular sentences. And so this is uploaded to Hugging Face as the LoRa-R1. Now, when you switch over to something that's more unique, like mole instructions, I don't believe that this is trained on the original Llama 3. Now, the original Llama 3 is designed, meaning that it finds information that it can pass very advanced, or let's just say advanced questions. Some of these being like college, chemistry or college medicine or these types of things. And, so it's trained on that, and it's going to have that core kind of knowledge. So when I chose this specific one, it spits out, it's kind of like Smiles format, if you're familiar with. It's like CC, it'll be like C double bond or, C, like a carbon framework. And I wanted to do with this specific one is start off with a smaller version of this 8 billion parameter. So I used its Unsloss 4-bit quantization. And what this does is it basically reduces the file size. So if you're at 8 billion parameters, I think it goes down to something like 5, 10, 15. If it's like 15 gigabytes, at least 15 or 20 gigabytes, it makes it like a half. Something like that, a half or a quarter, okay? So the reason why that matters is now you have more room to play around with your GPU. So if your GPU only has 40 gigabytes, like a nice A100, and your data set is huge, and I did get a question regarding this, it's like, it just depends. So if you wanted to use, fine tune or RAG, is that it just depends on how big the model is, how big the data set is, okay? So I used the minimum LoRa with this. Now, I think this one was significant because not only did it reduce training memory and model size by doing these two things to begin with, And I initially trained it on like 60 steps. So in LLMs, they don't use epochs, they use training steps, which can be confused with, steps with learning rates, but I wouldn't go that far. Okay. So here's the initial training. And then here's the second training. I increased the number of steps to decrease the loss to get this better biochem accuracy. And then I uploaded these as 4 and 16-bit. Now, a 16-bit upload on the model, like the one on the right here, I call it molecule 16. This is more the standard, okay? So the other thing you have to check is when you get answers in your notebooks, then how do each of these 4-bit and 16-bit models perform like out in the wild, So this would be, these are fine-tuned. So now I can take these, or somebody else can take these and then have them as a starting point in their next notebook if they're looking to use this molecular instructions data set, it's quite comprehensive. So here's what the notebook looks like. And I'll put up the links and all this stuff. And the previous posts kind of reflect this too, this is Llama 3 fine-tuning notebook. And, so this is the training portion here. And I had experimented with some of these, in particular, this numbers processing. It's there's a lot of, with Llama, you use 3 different types of parallel processing and architectures and these types of things. So I think the next step up would be 4, but I didn't seem to have much luck going from 2 to 4 or 2 to 1, these types of things. And then these other ones are definitely we're checking. Now, if you're in this position and you're training and the loss just keeps going down, but it just stops at some predetermined step, I wouldn't change anything else, and then change the max steps. Now, here's another tip here too, is I think it ends at 500, right? So you can't do 10x because mine cut off, but anything below 500, and it usually doesn't represent a huge part because you're loading other parts of the models, and that's memory intensive too, okay? So say, for instance, max steps, and then the learning rate you could test too. And if it's not decreasing well, so on some of these, I just got, goes up to 60 max steps, and I just switched it to 400. The loss was much lower. And then on top of that, my answers were a lot better. Now, that's not always the case that lower loss will give you better answers, but if everything's working well in a specific model, a lower loss would tend to give you better answers because it means its predictions are better throughout the training. And everything else you can experiment, but you can see the types of things with this Atom W 8-bit. There's just all of this, people want to create a model of a certain size. Like I said, I've been able to get down to about to half. And there's other, quantum inspired techniques like tensor networks you could try too. Now, here's the last one that I just finished up. So this is the heart disease data set using Llama 3. Now, the 8 billion instruct is what I see the most. It's more for instructions. And you could still have, use the original one that's 3-8B that doesn't say instruct. Now, what's giving it the RAG in this specific case, this retrieval augmentation, is this BGE small, and then I think this is English versus 1.5. So, and then this specific notebook I got on GitHub from this Sakil 786. So when I did this specific one, I gave it a battery of questions, and it was so I get the data set from UC Irvine, I upload it to my Colab, and then I access it, through this Colab mount through Colab. And, it actually, when I compared it to the original Meta.ai, they were similar in performance because Meta.ai also saw this heart disease data set. And that wasn't something that I originally thought. However, when I gave it this one very specific question about what happened to the Cleveland.data file, inside the data set, there's a small file you open up and it says exactly. So my responses I got for this using RAG, every time you train, you're not going to, it's never like, you can't get the whole world's information. So in RAG, what RAG did in this specific case is really focused on that specific data set I provided. And for this one, it gave a lot better answer that highly reflected what the original file did. But that meta.ai on, I believe, a lot more parameters didn't pick up, as a general model. So be concerned about these things. So this is what it looks like in here. So you have the base model, this 8 billion instruct, and that's mostly what I've been using. Now, also, when I posted this on LinkedIn yesterday, I would really go through and understand what temperature is, because it adjusts the types of responses that you get and your top P and probability of these types of things as well. And here's the RAG portion. So this BAAI, this is the author, and then it's basically doing the retrieval off of the data set, the heart disease data set. So on the first go, it said briefly explaining about the model architecture of Llama 3. So this would be an expertise question that the base model would be good at. Even if you wanted to use your own specific data set, it probably wouldn't need to be RAG or whatever that term is. You wouldn't need to do that in addition to what it was already trained on, because it's going to know about its own architecture, right? So, and again, it's the same type of concept as you would want to fine tune on data sets that are aimed more towards what the model's expertise is not at. And again, you really want to see, because they'll post benchmarks on the websites as far as, what exactly, basically it was trained to exceed on these specific benchmarks, and it'll just give it like college classes. So if you haven't been there yet, I would definitely go to, this is meta.ai. Okay, so for some of you, this might be new, for others not. And again, if you type in imagine, it switches over to this different format, and you can create little GIFs and stuff like these too. But I use it, and I'm going to be using it, for Llama, as basically a very specific a benchmark. So like I said, it appears to be based on the 70 billion parameter. So if you could do something better on your 8 billion with RAG compared to this, that's a good achievement, right? Okay, are there any other questions at this point?
Kevin, I have one quick question. This is on the project where you spoke about cancer data set with four databases. Was it structured, unstructured? Was it structured SQL, NoSQL database, or unstructured data set?
I'm not sure about SQL. You could see it. It's on UC Irvine. It's called heart disease. So
okay. Sure.
yeah, it comes up as heart plus disease, and it actually is based in 1988. I think it's just for heart disease, and the 4 databases are like Cleveland Clinic, and there's 3 other ones too that are hospitals, I believe. And you'd want to use something. You want to use in specific data sets that aren't. You just type into Meta or not GitHub, but OpenAI with ChatGPT, and see if it can answer specific questions. Because I can ask questions about the specific doctors. I think was the other one too that the big model it was not good at, but my specific one that's fine-tuned, it's better. So yeah, that's all on UC Irvine.
Oh, sure. Thanks, Kevin. I mean, the reason I asked was on unstructured data sets, RAG has been used very widely. I'm trying it for structured data set. So yeah, if it works on that, that'll be great.
Yeah, I mean, the other thing, because even neural networks aren't really associated with structured data sets well. It's more of like a tensor network thing. And, it's these combinations of these driving into the future as far as like what would be the best to use in each circumstance.
Absolutely. Cool. Thanks, Kevin.
Any questions? So yeah, this is kind of like the big kind of push, to get everybody on the same page that follows every week. And if you have to understand LLMs, and I get these questions asked before, what should I do? I say, well, go to other groups. There's machine learning groups. There's one, at least one on Saturdays, advanced for San Diego. It's online, or it's been hybrid the past couple of weeks. There's another one Sunday morning too. And these people are it's just week in and week out. It's part news, it's part technical. It just depends on who's there. Did you have something, Anu?
Yeah, Kevin, I have a question that is not directly related to, your talk today, but on the uses of, the models. You used, Llama 3 this week. I guess it just came out, right? So, like when you, import it or run it, do you use it on Colab, Google
Yeah.
Colab?
Yeah, so I had to sift through a bunch of demos, and I actually started off on these. They were kind of adapted from Llama 2 notebooks, and then somebody just put up using a thing called auto-tune, which I was able to get up. I think just they're called adapter weights, which wasn't like the full model, and I think that's where things were missing there. And then just all of a sudden, people put up different notebooks that are more modern, and especially with parameter efficient fine tuning or PEFT, which is like LoRa, these types of things, and it gets into that's a field on its own as far as how to get the highest accuracy based on using the lowest size of the weights, those types of things. So yeah, I'd say that the two big ones are definitely the ones I mentioned. So this is the RAG one, and so I mentioned before, I think it's Sakil 786, something like that. And then, so I already did a development on this based on, asking it specific questions regarding to the heart disease. And this one was a lot more straightforward. And I say to get up and running, and especially with the trend of, I think, RAG these days, I think this would be a good start for you. So it's, again, I'll have it up with this specific one. And also, it's in my previous LinkedIn post the last couple of weeks.
So, like, I tried, one of the codes that had pipelines, and I just tried to run it locally on, a CPU machine, and it just didn't do much because maybe it was too heavy. I just wanted to ask.
No, pipelines is very lightweight. I mean, it does depend on, as far as the code, like it should only be 4 or 5 lines of code, but it depends on how big the model is that you're trying to run and those types of things. Now, I'm not familiar with running it locally. Have you looked into as far as local Hugging Face? Because I remember in different types of AI that they would run into that issue as they work at a place where they can't do things on the internet. So I think that would be your starting spot is to fix that one. But when you go to run them, as long as you have, it's just accelerator and one other package, transformers. So transformers, accelerator, and I put up the demos. So yeah, I think that's the biggest thing is make sure how you can run it locally.
Yeah, so I installed transformers, and it did not have any syntax error. It just was, hung up. And the reason I was, asking this is, I'm not sure. Maybe you're using GPUs to run.
Yeah, it doesn't that's it. I'm glad that you mentioned that because it doesn't like CPUs. All the code that I've experienced is GPUs. Now, this one in specific, this one's a little bit different. And for instance, if I want to run like a 70 billion parameter, I might be able to use a really big TPU because I don't have a huge GPU. But yeah, just across the board, everything seems to be GPU. And you should be able to get decently far, like T4, V100. If sometimes if they don't have an A100, then they'll switch you over. It's called an L4. But the other issue you're going to run into is if you're running experiments in a set, is you're going to be using a lot of GPU time in a condensed period. And then that can cause issues too if you have to log off log back on or wait to get it again. Where the A100 is by far the most, as far as collab, the most in demand. So and you lose some things switching to a V100 besides just the speed. There's other things as far as bits and precision, and it's called, I think, BF16, that you can't do on a V100. So yeah, I mean, just to get up and running, I would do something like that. It's just, figure out if it's the local issue. You install all of that, because it's so dependent on the models. It's basically a model repository online, and that's kind of what you're up against.
Mm-hmm. Yeah. I mean, I do have access to GPUs. It's just I did not use it. I'll try that again. And I mean, here you're dealing with text queries, and I was mainly trying the smiles generation or smiles to structure generation, those kind of things, and I found one repository for drug discovery.
Yeah.
And yeah, so I'll try again and see if it changes anything. And sorry, one more question. Do you use the like your account on Hugging Face to push to, or I saw that you use on GitHub. So do you only look at Hugging Face for your information and do all the things on GitHub, or
Usually,
like?
yeah, I usually get the notebooks off of GitHub, but then I run the models, and that just depends. Now, what you're going to run, especially with Llama, you have to be approved. It's, it shouldn't be an issue, but you go on to Hugging Face, and then you I think type in your email address or something, and then a short time after you should, if hopefully you get approved, and then you go back into Hugging Face, and they're called writable or read tokens, and then you say, I want a writable token, and then it'll generate one, and then you just copy that. And especially in the notebooks that I've faced here too, is you would just, paste it. Now, the other way to get into Hugging Face, it just depends on the model, is after I sign into like my collab, my directories, is that the next one I would log in, it's like Hugging Face login, it's in the notebooks. So, and that will sign you in for the whole notebook. And you may be able to, as opposed to copying and pasting in multiple cells, for your tokenizer and your LLM, your specific writable token. Or yeah. So, but they're two different things. Tokenizer is separate from the Hugging Face token.
Okay.
Yeah, and just
Thanks.
get one up to run. I mean, the thing with the other one here, which was the Unsloth, which is the fine-tuning one, this is, there's more working pieces because you want modification to train better. So this is the one I switched. I said I couldn't go up to 600 steps, or they're essentially epochs. And then I stopped at 400, and it gave me significantly lower loss, by half. And it also made my outputs a lot better. So that's just one of those things, as far as, instead of diving into learning rate or, batch size or some of these other things, is if it's already decreasing in loss, just run it longer, and that's what helps on this mole instructions with actually they call it selfies, which is kind of like smiles, with that specific format. So, this one, it pretty much just ran out of the box. The hard things that I got into was it's called pushing to Hugging Face, because say at a specific point, it'll only send the adapter weights, which are not the full LLM. And then another point, I can send it as 16-bit, which is, like an original, I mean, it's not full precision, or 4 bits, and I'll send both, right? So in this specific one, this 4 and this 6 corresponds to the compression, basically how big the model is. And like if the 16 is about 8 billion, the 4 was like a 4.5, something like that. So that's another thing too in all these things. But I think, based on all of these developments and, the first Llama, I believe, came out early last year. The second one, Llama 2, was later last year. So they're doing like two a year. So it's moving at a good pace, right? And if you ask that question to different meetups, like for machine learning, as far as like, well, how are you going to like, is this going to be like a Google search? And it's like kind of, right? So it's based on RAG, and then how much additional live information, or, if you're hospital, it's like, the local information, or if you trust other websites, it could be other live websites too. So the moral of the story is it's don't look at it like it's highly complex. Look at it as like highly configurable. So, it's whatever these options exist based on what your goal is, right? If you don't have much GPU time or resources and you want to try RAG right away, that would probably be the best starting point. And like I said, it was just very specific, especially in one of my responses, saying what exactly was in this file, why this file wasn't included, and why a new one was included, where the general model didn't have that level of detail like the RAG did with RAG data. So yeah, the other thing is try to figure out, if you can, what hasn't been done and what has been done. And if you're just starting, say you want to do a Llama 3 update to Llama 2 application in medical, that might be granted, if you can get better, accuracy. I think some of them, they'll work off of multiple data sets to pass these medical entrance exams as a benchmark. So yeah, figure out what's most important. I put up a poll, I think yesterday, is it the size of the large language model, or is it, the output quality? Is it the accuracy? I think for a lot of people, or even is it, does it have references? And that's something that RAG in the output can give. Or is it the input complexity? So can Llama 3 have more inputs than Llama 2? Meaning if you want a protein with like, 10 attributes, can it do that as opposed to just 4 or 3? Is that something that's possible? So, and if you're just, everybody else too, feel free to put it in the chat if you have any questions. Now, if you're just starting on Hugging Face, if you look in the upper left-hand corner, this will save you some time. It says text generation, or it might say text to text, or text to video, or text to image, or image to whatever, or multimodal. That's a good starting point too, right? Because what do you want to do? Do you want to create images for scientific work, or do you want to do whatever? Is it just easier to type it into meta.ai? Or I would say all of these things, with fine tuning, and especially with RAG, it's going to really shine on your specific data set that was not included in the training of the original Llama 3s. Okay. Because, right, it can't, that's the weakness of the big model, right? It sees a ton of like 15 trillion tokens, but there's still way more data than whatever, it's gathering context, but you want specific things returned. And I think if you could go back to your boss and say, oh, okay, I ran this in RAG, and it gave me very specific details without having to even look at these, whatever 4 databases worth of files. And it summarized it correctly, and you manually check it, and you say, oh, okay, I found the same thing too when I read that too. And then metadata AI didn't say that because it's, it doesn't know about your data set. So those are the types of things. That's the power. It's the like configurability to your specific application. And feel free to put it in the chat as well. So, as far as where you're at with it, if you're just trying to run a notebook, if you're trying to get up, push a model to Hugging Face, have you pushed models to Hugging Face, these types of things. And I had to struggle with several notebooks before I found these 2 that I included. And it didn't feel productive because I kept thinking if I change this and change that, and I wasn't in the ballpark of where I needed to be. Right. So that's another big thing is finding the good starting tools. So like I said, with these two, with this one, and then with this one, these are just small clips of the code. And there's just a thing. So say, for instance, in this RAG one is instead of doing a data set, it's actually a directory. So you're uploading a directory from whatever Colab, your drive, through Colab, or if you're doing it locally through Colab, typically you do it through Drive. And, based on what was found in that directory, and the context comes from Llama 3, this 8 billion parameter, but now it's pointing towards your specific data and, giving you, like, say, like, what was the doctor's name and whatever. So whereas maybe the main training only has like the bulk of the results, something you would put in the paper as opposed to like just all these extra details now you can get to through RAG. But yeah, any other kind of questions about anything here? And it's going to be fun and exciting times because I don't think getting a new utility is that far away for what I do, like with drug discovery. And my background is all like chemistry, biochemistry. I had a research project that was like a micelle polymer that we would synthesize and then characterize, and then we'd put some hydrophobic drug in, and then it would collapse, like kind of like a cancer drug, inside a patient if it was introduced at a certain pH or inflammation, so that was the goal, is to build these medicinal polymers. So, like I said, and the other question too, from Anoop is good, because I have to ask myself too, it's like, I just can't just see one thing that works. Now I know I have a pretty good idea, the data sets to try to use, that I could say, what would be something new that isn't just a 2024 version of the Llama 2, so. And the other thing is, like, it's moving so fast because I did some work, and Anoop was talking about I think it was a Prot GPT-2, and then I also did a ProtBERT, like protein versions of these two. And the performance of the base models are so under like a Llama 3, like a GPT-2 that's open source, and you can adjust weights or you can adjust architecture. With Llama 3, it's literally cutting edge. I think in some of these they've got better performance in certain cases than ChatGPT 3.5. So, and it's open source, and you can modify those types of things. So the reason why I talk about it so much is because there's really not too much else, because everybody tries to make it proprietary, and you can access it or ask it questions, but you're limited in more other things. But yeah, I take notes in my phone as far as like the next steps to take, and that would be one of them is, say, okay, based on all of this that's been done with medical chatbots, these types of things. Noreen, go ahead.
I didn't want to really interrupt you, but I just have like a general question. So if you use these kind of AIs to predict, like to discover a drug, right? How accurate are they? What is the, number of, can you give me like a general number with regard to like how accurate they are?
Yeah, the closest number that I saw, I did a notebook. It's based on an MIT. It's basically a molecular strength of the proteins, and the way they measure it first in the lab is they use atomic force microscopy to get the values. Now you have those values, the AI trains on it, and then the proteins that are generated try to match the force curves that are desired. And then that specific one, it was better than other competitors. So their R squared was like 0.1, maybe 0.15. And for their specific one, they were like 0.4. So, and that's a really good question, because that's a goal, right? Because we want everything to be closer to 100%. Now, They also did it based on secondary structures to say if they wanted a specific secondary structure in their protein. And I think that one they had a higher accuracy. But something like an end, like a pull strength, like a force, you know, everything in the paper seemed to say that was a harder task to do. So it just depends. Like if you just say like these, like solubility or molecular weight or isoelectric point, these types of things are a lot easier. But something they call this end to end. So meaning I need a protein that's this strong, and you know that's kind of how they wound up as this R squared of 0.42.
Okay. All right. Thank you very much, Kevin.
Yeah. And like I just did a poll on this because it's, you know, output accuracy is obviously a huge goal. Same thing with kind of input complexity as well. Yeah. So there's another one. And do you want to explain that, Anu?
Yeah. So Kevin, this is one of the profiles I found on Hugging Face regarding, you know, my core interests, and also related to what Noreen was asking right now, you know, the use of AI for the problem of finding the drug molecules. So this user, he has a, you know, a code where one can input the protein sequence and also ask for, you know, specific things like the number of molecules that you should try. And yeah.
It says GPT. So does it say in specific what they're dealing? Is it GPT-2 or?
Yeah, so it's a GPT-based strategy for designing potential ligands targeting specific proteins. And this is from 2023. So they don't mention the GPT version. But yeah, it's like trained on 1.8 million protein ligand binding data, drug GPT.
Yeah, I mean, it makes a huge difference because these are the different classes. So right now they're calling like Llama.
Sorry. Yeah, so it's GPT-2.
Okay. Yeah, so I would say that probably if you want to do an update or whatever on it, but that model is not nearly as powerful as Llama 3 or GPT 3.5. They kind of put those together as far as size. And I think even the Llama 3 is less than the 3.5. But it makes a huge difference. That's your starting point. They put like Facebook just put $100 million into Llama 3. You really want to be using the most recent models. And, you know, if they did it and if they said it was awesome, I probably wouldn't do anything with it because why waste your time? But, you know, if they kept finding that the accuracies were low or it didn't have enough context or, you know, the especially the outputs were of low quality, continuously, like low accuracy, then that might be a thing where, you know, if the data sets are open source, a lot of times they are, to use it with Llama 3. And like I said, with the either the Unsloth or the other one from GitHub with a RAG, or using both. Like, so you would typically, I think you'd fine tune your model first, then use your fine tune again on that same RAG data set, and then, you know, might be lights out. But it's not guaranteed. You always have to do the experiments. But keep that in mind when you find these different ones, because I do come across, you know, similar types of things as this application is what was the base model it was trained on. And I think a lot of these you could do a lot better on as far as just doing RAG on their Hugging Face model and then use their data set again. And that should do it, right? Because, you know, it's kind of old software, right? So that's the big thing is, you know, figure out what you want to do and then also, you know, use the most current models.
Yeah, thanks.
Yeah, and there's things that you can do analogous because say if GPT-4 is better than yeah, it's not as fast, but like I think that's still the consensus that it's probably be, superior to Llama 3, like 8 billion. But, there's still 70 billion. And there's other advantages to doing RAG is you don't have to, you're not training on it, right? So you don't need that, whatever. If it's 40 gigs GPU that you have to work with, then you could start to incorporate bigger models with RAG, right? So that calculation of how much RAM do I have left is a lot smaller because it's based on, the base model or somebody else's fine-tuned model. But the training process, takes a lot more RAM. So yeah, I would definitely, and you hear about RAG, and I think it got big, like I said, later last year. I saw this NVIDIA post, and I would hear it in one discussion. They just kept mentioning the name over and over. Prompt tuning as well. So I wasn't able to get to prompt tuning this week, but just keep in mind, it's not always the trend for the hugest parameters, finding the biggest GPU to train on. Like I said, you might not even have to train. And any other questions, like I said, feel free to put in the chat. If you have any other links you want to share in the chat there too. Now, one thing I didn't cover as much is you're going to hear about PEFT. So when you get further and further with LLMs, it's parameter efficient fine tuning. And it's basically saying of the 1 to 10% of the parameters that you're fine tuning on, you can approximate those weights instead of, going through however much RAM it takes to do that and still get a good solution, right? So whatever the end goal is, your output, like how well does it solve the output? If you retrain the whole model, which I wouldn't recommend unless you know what you're doing, or using just full weights but fine tuning like 1 to 10%, or using parameter efficient fine tuning. And most of the times mine would only run on a 40 gig CPU, fine tuning off of 8 billion Llama if I was using parameter efficient fine tuning like LoRa, or low rank approximation. So yeah, I mean, it's a type of thing. If you got hooked into ML and AI before, it can happen again with LLMs. And I wouldn't fall into that trap of saying it's just too complex, there's too much going on. I would say, oh, I want to configure my model to do this, and then I have to modify this in order for that to happen. And everything else, I'm not going to, let's just take it one step at a time. So any other questions? So we talked about Hugging Face, Colab, GPUs, and everything with RAG, fine tuning, these types of things. And this question comes up in my Sundays is students that want to start in a field of machine learning. You might not think you can start with LLMs, but I believe that you can, because everything, it has a learning curve, and you're not going to know like a million things, literally like 100 million things about the original LLM, the pre-trained version that you're using. You just take it for granted. They put a lot of time and effort into making this good, basically a foundation model, and you go from there, and then you're doing your steps, but you don't have to know everything, right, about the original base model if you're just trying to get a better outputs for a client based on the specific data set. Now, doesn't that sound like a lot easier than thinking that you have to you need these like 7 GPUs to fully retrain a model without fine tuning or RAG? And you see what I mean? Like I just get that sense from people. It's like it's either all or nothing, but you have to chip away at it, and eventually the significance of your results will get better if you don't give up.
Yeah, it makes sense.
Yeah, and some extra kind of, if you're still on the fence with it as far as coding with LLMs, is that they did some polls, and these are human artificial intelligence. It's Stanford HAI, and they said that the majority of the Fortune 500 companies are buzzing about Gen AI, right? So that's one thing. And you see all of these like just crazy amounts of money being spent just to train a model on, in this case, 15 trillion tokens, or, you know, however big the next 400 billion one is. Like, it's just like, that's the area to be in, right? If there's other layoffs in other areas, I think it's probably one of the safest fields to be in. That's why I chose it. And I'm going to be incorporating quantum inspired tech into this, like architecture stuff, but not now. And but you have to get grounded in it. And the biggest thing that you can gain, you know, as a researcher, is just take one of the demos, either the one I posted, which typically I put all the installs and whatever else you need into it, and just run it. And the biggest success is just telling people you just ran a model. And then the next step might be you just pushed it to Hugging Face, right? As a 4 or 6-bit, and that has those options too. But it's just one step at a time, right? So I would say the biggest issue, you know, is just not doing anything and then coming to that conclusion is like, oh, okay, you know, I can do this. It's not going to be the, you know, solving the world's problem tomorrow, but I'm just going to chip away. Go ahead, Noreen.
Oh yeah, I was just thinking about the YouTube videos that you have up. I subscribe to your YouTube channel. If there's any particular order in which one should watch those videos, do you think you could compile a list maybe and put that on your YouTube site? Is that
It's always the
possible?
most recent ones, because whatever I'm talking has, you know, the past, you know, 2 or 3 especially. And if your background is biochemistry, I would definitely get the Gen AI. It's the MIT researchers. It's the end-to-end protein generation. You were asking about the best accuracy, and you know, so that's a great one too. But yeah, it's just the most recent ones, because you know everything has to get up and running. So meaning like I have some good results so far, and I was able to prove through RAG that, you know, my specific data set, I couldn't get that information through the core, like even a 70 billion parameter model. But yeah, it's that. And if you look at my GitHub, or it's medical quantum machine learning, if you go down, it's always the ones on the bottom are the most recent. So if it starts at like 32, something like that, and those reflect the LinkedIn posts as well. So I kind of do mirror sites for the other social media, but
Okay, thank
yeah, I
you.
think the biggest thing is just to take the jump, you know, and I think that's the thing that people are afraid of. Either, for me, it was coming back to chemistry because it was just hard moving out here. But now I have all this tech, right, that I've had good results on. And now I can start to incorporate into Gen AI. But yeah, just I think the biggest win, everybody, is just run a notebook to completion. It sounds stupid, but say for instance, a good mentality to have is just go onto GitHub, type in like Llama 3 RAG, and then they'll be the most recent ones, and then just download each notebook, run it, and that's how I found one of these. So a lot of it's not rocket science. It's more like hard work and perseverance, and you just do whatever it takes.
Okay, thank you.
Yeah, and definitely, like with anything, it's not everything I found with LLMs. There's a lot of development, so you're gonna, in my opinion, come across things that just work better, right? Because there's more people that want to upload models, download models, use certain things, and that's my experience so far. Is that it's not old software that it's like we're just holding on to. I mean, even LLMs, a certain part, there is a classification that is made. I mean, it's not a classification model, but I think the thing that you have to convince yourself is like, this is the new cutting edge stuff. And, drug discovery is the #1 application. I think it was Fierce Biotech found, for medicine, for generative AI.
Mm-hmm.
I didn't know that, right? I was between that and diagnostics, and based on my background, I chose drug discovery.
Mm-hmm.
So, right, like I said, but the world's going to lag behind some of the things I talk about because they think the only thing out there is a specific, web chat, a large language model. but you could do all this stuff locally, just have RAG pull in more information, more live data of the sites that you trust. So you're not necessarily entering in, whatever information that you don't, if somebody accidentally copies and pastes something about a patient, right? That you don't really want to submit that if it's to some other place. So I think it's just pulling it all together, and the technology has gotten strong enough, especially with these Llama 2 chatbots. It can pass medical tests. It can do, I've used even GPT-2 for protein generation, and that's a smaller or previous model. So I think it's at that point where it's just like, yeah, all these problems are solvable, that people talk about in medicine, and to fully embrace it. So I think on one end, with San Francisco Bay Area fully embracing it, and then, everybody else, there might be some concerns. It's just lack of other information, like that this technology exists, but in your specific, like, safe form.
Okay, great. Thank you very much.
Yeah. Any other questions? Anybody we haven't heard from? Is it Abhinav or Saket?
Yeah, well, I can add that for a lot of these use cases, beyond drug discovery, also it's useful for like doing RAG is useful for retrieving information on, say, like publicly available databases of like drug labels and other types of resources and data banks that are out there for use. And also, when it comes to those things, taking into consideration things like how do we kind of process the data, like pre-process the data, and different things like that. I feel those are all the different considerations as these models get bigger, as these models get more robust. But how are we processing the data? Like, how are we parsing everything? How are we putting everything together? I feel those are important considerations.
Yeah, I appreciate you bringing that up, because, accessing whatever you need, publicly, and there'll be a whole scale, but it's like, it's the same. The FDA arranges everything by probable benefit over probable risk, right? And I think the issue now is not that. I think it's just the information that the software exists if you want to run it locally or do whatever. But yeah, ultimately you want it to be, way on one side of like, okay, this is something that we have to do. It's, we've proven that the way that we do it is safe, safe and effective. So awesome. Anybody else? And I appreciate everybody coming on. So yeah, this has been Wednesday, April 24th, actually 25th, 2024 for, this is Meta Llama 3 fine-tuning RAG and prompt engineering for drug discovery. I appreciate everybody coming on. Have a good rest of the night, and have a productive rest of the week. Take care, everybody. Bye.
Thank you very much, Kevin. Bye
Thank
now.
you.